Okay, this is a sequence and series question. It says a sequence is defined using the recurrence relation un plus 1 equals a un plus b. So what this means to get my next term, I take my current term and I multiply by a, and then I add b. So that means to get your u2, for example, you would do a times your u1 and then plus your b. So we'll use that to set that up because it says in this, what you're to do in this question is find the values of a and b, and you're told that u2 is 210, your u1 is 150, and then you've got your b. So two unknowns and one equation so far, so that's equation 1. Same idea, u3 would be equal to, and then it's going to be a times my u2 and then plus my b. So that means 288 in this case is equal to 210 times a plus b. So I've now got two equations, two unknowns. Let's just write them down again and go for it and solve these. So hopefully I have written those down correctly, and then we are good to go. So you can see you've got the same number of b's in each equation. What I would just do, I'll do equation 2 minus my equation 1. So 288 minus my 210 is 78. And then that is going to be equal to 210a minus 150a is 60a. That means my a is equal to 78 divided by 60. So let's just do that in the calculator and see how that cancels down. And that's just 13 over 10. So a is equal to, I'll write that as 1.3. And then put that into the equation 1, sub that back into equation 1. So 210 is equal to 150 times 1.3 plus b, which means a wee bit of working out. Your b is 210 minus 150 times 1.3, and that b works out to be 15. So you've got your b is 15 and your a is 1.3. Okay, so that was just using the fact you've got your recurrence relation, and you can also use it to connect u1 and u2, and also you can use it to connect u3 and u2. Okay, right, next question. Okay, it says write each of the following series using the sigma notation. Okay, first of all, I want to find an nth term for this. I'm not too sure what the nth term would be. So I would just use the common difference. So to get from -7 to 3, -3, add 4. Okay, lovely. So it's just adding 4 every time. So the general term then, if you go back as well, so the general term then, the un has got a 4n in it. And if I go backwards, that would take me to -11. So 4n minus 11 is my general nth term. I need to find out what my first term is then, and how many terms there are in this. So first of all, let's just check. u1 is equal to 4 times 1 minus 11. So u1 is equal to -7. So that works. That's fine, obviously. I didn't really need to do that. I want to check what term my 25 is. So 25 is the same as, we'll say, 4n minus 11. I need to find the value of this n. So 25 then plus 11 is equal to 4n. So that's 36 is equal to 4n. So n is equal to 36 divided by 4. N is equal to 9. So that's my u1, my first term, and 25 I now know is my u9. That's my 9th term. So write the following series using sigma notation. So it is a sum of, and you could say 4n minus 11 from n is equal to 1 up to n is equal to 9. That would be one way of doing it. They may have written it in this form as well. You could have said that's just n is equal to 1 r. I could say r is equal to 1 up to 9 of 4r minus 11. That would also work. There's loads of ways of doing this, so just take my word for it. They are both correct. Those ones. Okay, right. This one, pardon me, is a little bit more problematic. I'm going to rewrite this sequence. I'm going to rewrite this sequence here as, instead of 6, I'm going to write it as 6 over 1 plus 7 over 4 plus 8 over 9 plus 9 over 16. Now, clearly I haven't changed this at all. Clearly haven't changed how the value of it, I've just changed how it looks. Now I might do the top line and the bottom line as two separate sequences. So we're going to look at 6, 7, 8, 9. That clearly is, you're going up in ones every time. So there's the UN for the top line is just 1n. And if I went back by 1, I'd have 5. So it's just n plus 5. My bottom line, it is just 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is that. So my bottom line is just n squared. So my general term, my overall nth term then, my general term overall for the whole thing, top line is just n plus 5, and the bottom line is n squared. And that is my U1. And, oh, sorry, it goes on, dot, 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 forever and ever and ever, amen. So it goes on to infinity. So up to U infinity. So your summation, it's a sum from n is equal to 1 to infinity of n plus 5 over n squared. And that's going to be it.